everybody, and welcome to this video on trig equations. In this video, we have a look at finding a specific solution. So what do I mean by that? If you recall, in the first video, we spoke about the difference between a trig equation and a normal equation. And it was that for a trig equation, the solution repeats itself several times. So if you watched the video before this, then you'd seen that we have found a way of getting the general solution, which outlines the solution for all of the values that lies from minus infinity to positive infinity. However, what we're going to be looking for in this case is the specific solution. So we're looking within a certain interval for answers that lie within that interval. So I've broken it down into some steps, and you would notice that the first three steps are very familiar. It's the steps that we have used to find the general solution. So basically, we find the general solution, and then we substitute values of k, and we look for solutions within a particular interval. So I think the best is to jump straight into an example. So here we have that 3 tan x is equal to 2. The first step that we should do is we should make the ratio the subject of the equation and find the reference angle. So we have tan x is equal to 2 over 3, and then we use the inverse function to solve for x. So we have that x is tan to the power of minus 1, 2 over 3, and then this here is then our reference angle, which is, so typing that into your calculator, we get that it is equal to 33.69 degrees, rounded off to 2 decimal places. So that is our reference angle. The next thing we're going to have to do is find the general solution. So I'm going to remind you of the diagram that we have here that tells us which quadrant the difference ratios are positive and what is the general solution. So in the first quadrant, the general solution, since we're dealing with tan, our period is 180, it would be reference angle plus k times 180. This would be 180 minus your reference angle plus k times 180. In the third quadrant, the general solution would be 180 plus your reference angle plus k times 180. And in the fourth quadrant, would be 360 minus your reference angle plus k times 180. Now we have here that tan is positive, so tan is positive. So we're looking for the solution where tan is positive, and tan is positive, as you can see in the first quadrant where everything is positive, and the third quadrant. So we write out the solution for the first and the third quadrant. Okay, so in the first quadrant, our x will be equal to our reference angle plus k times 180, and our reference angle is 33.69, so that will be plus k times 180, where k is an element of integers. So that is our general solution for the first quadrant, and in the third quadrant, we have that x is equal to 180 plus our reference angle plus k times 180. So we have that x is equal to 180 plus 33.69 plus k times 180. So here we have that x is equal to 213.69 plus k times 180, where k is an element of integers. So this that we have done is the general solution. So this what we've got is the general solution. And what now we would like to do is find the specific solution, which is the values that lie between minus 180 and 180. So I'm going to substitute different values for k. So for the first one, I'm going to substitute k is equal to 0. And if we substitute k is equal to 0, we're going to get x is equal to 33.69, which does lie between that interval, so that means it is a solution. I'm going to substitute k is equal to 1, and then we would get that x is equal to 213.69, which you can clearly see does not lie in the interval, so that's not a solution. And then I'll try k is equal to minus 1. And then we get that x is equal to So 33.69 minus 180, because now we have minus 1, which is minus 146.31, which actually does lie in this interval. So the specific solutions for the first one that lies in that interval is when k is equal to 0 and when k is equal to minus 1. Then our answers are 33.69 and minus 146.31. Now let's do for the third quadrant. So when k is equal to 0, then we get that x is equal to 213.69, which is not in the interval that they asked us for. When k is equal to minus 1, we get that x is equal to 33.69, which is in the interval. And then when k is equal to minus 2, we get that x is equal to minus 146.31, which again is in the interval. What you notice is that then we have this as a solution and this as a solution. I won't go more negative because then we're going to go out of the interval. But what you notice is the two answers are the same for these. That's because a tan graph has a period of 180 and the third quadrant is just adding that 180. So you're getting the same solutions with a delay almost. Okay, so please make sure that you've understood these examples and how to get the specific solution, and watch more for more information on your trig graph.